Namaskar. So, in today's lecture we will discuss about another concept called duality. Duality is applicable for various engineering applications, but in this particular course we will particularly discuss about duality in relationship with the electrical circuits. So, let us understand what is duality. So, when two circuits are dual, that means the mesh equation that characterize one of them have the same mathematical form as the nodal equation characterize the other one. What does it mean? It means that if you write the mesh equation for one circuit and write the nodal equation for another circuit, the mathematical forms of both of the equations would be same. If you recollect what we say for voltage around capacitance, we say not voltage, let us first say what is the current across the capacitance. What we write? We write it is at C dV by dt. What is the voltage across an inductor? You will say this is L di by dt. So, if you see these two equations, both looks similar in mathematical terms, because both have one term before the derivative, that is d by dt of V and d by dt of current I. So, from mathematical point of view, these two are having the same mathematical form, that is why these are dual. So, what happens in that case? You can say that current across the through the capacitor would be dual of voltage across inductor, capacitance would be dual of inductance, and similarly voltage across capacitor would be dual of current flowing through the inductance. So, in this way you can say that the various elements and the various electrical variables of the circuit are dual. Now, these are exact duals if each mesh equation of one circuit is numerically identical with the corresponding nodal equation of the other. In that case, we can say that both of the circuits are exactly dual. So, what does duality means? Duality refers to any of the properties exhibited by the dual circuits. Now, let us understand this concept with respect to one case study. So, let us see one circuit which is shown in the figure. What we can do? We can write first two mesh equations. We define mesh currents like I1 and I2 in this case. We can write the mesh equation. How we can write? The current I1 is flowing through 3 ohm resistance. So, we will write 3 I1. Then the current flowing through inductor, I1 is in this direction while I2 would be in opposite direction. So, it will be I1 minus I2, and since we know that the voltage across inductor is given by L di by dt. So, this will become L into d of I1 minus I2 by dt. So, this will become 4 d I1 by dt minus 4 d I2 by dt equal to 2 cos 6t, which is the voltage in the mesh. Now, in this particular mesh, what we have assumed that there is an initial voltage across this capacitor, which is given as Vc, and the value of Vc is 10 volt. So, how you will write the mesh equation? You will write the mesh equation for this second mesh as 4, that is the inductor value, into d of I2 minus I1. So, that is why 4 d I2 by dt minus 4 d I1 by dt term has come. Now, we will reach the capacitor. So, voltage across capacitor is given by, since current IC is equal to C dV by dt. So, voltage Vc would be, if you take integral of both sides, then you will get the voltage across capacitor. So, this will become IC dt. So, in this case the value of voltage would be 1 upon 8, that 0 to t, let us say time t you are finding out the equation. So, 1 upon 8 0 to t I2 dt would be the voltage across capacitor, plus 5 times of I2 for 5 ohm resistance, and then equal to minus 10. Why minus 10? Because the direction of current I2 is opposite to the initial voltage which is across capacitor. So, in this way we get two mesh equations for the circuit. Now, what we have to do? We have to construct two equations that describe the exact dual of our circuit. So, since the previous equations were mesh equations, so dual of mesh equations are nothing but node equations. So, what we have to do now? We have to write the nodal equations. So, what we can do? We can just replace the mesh current with the nodal voltage and we can write it. So, in this case I1 is the mesh current. So, we can simply replace I1 with V1 and I2 with V2, and we can write the exact dual of these two equations. So, what we will write? 3V1 plus 4 dV1 by dt minus 4 dV2 by dt, because here di1 by dt minus di2 by dt is there, and then 2 cos 6t. So, this will remain same from value perspective, but not from the source perspective, that we will discuss when we will go forward. And then this will become minus 4 d I1 will be replaced by V1, I2 will be replaced by V2. So, minus 4 dV1 by dt plus 4 dV2 by dt. So, this has come, and then I2 will be replaced by V2. So, this will become 1 upon 8 0 to t V2 dt plus 5 V2 equal to minus 10. So, now we have got the two equations for nodes. Now, if you see these two nodal equations, you can easily verify that they are essentially two nodes. So, what we will do? We will first analyze these two equations and try to find out what does it mean. So, when we see these two equations, we come to know that there are two nodes. So, what we will do? First, we will draw a line to represent the reference node, because reference node is anyway required, and then we stabilize two nodes at which the positive reference for V1 and V2 are located. So, what we are doing? We are creating one reference node that is anyway required, and then since we are using I1 I2, the dual of them would be V1 and V2. Now, if you see equation 3, it indicates that the current source of 2 cos 6 t ampere is connected between node 1 and reference node, because this is nodal equation and this is representing the current value, which is anyway representing for only node 1. It means that this current source is connected between reference node and the node 1. So, what we can do? We can create one current source with equal value, because voltage is 2 cos 6t, current will also be having the same magnitude, that is 2 cos 6t, but in this case this is now current source, and this will be connected between node 1 and the reference node. Now, how we will define the orientation? If you see the voltage, this voltage is giving positive current, that is the current in the same direction which we have assumed I1, right. If this is the case, then corresponding dual current source would be nothing but giving current to the node. So, it means that the current source having direction going inside the node V1. So, in this way we will say that the current would be entering node 1. Now, if you see equation, it has another component called 3V1. What is 3? 3 is nothing but conductance, because this represent the current value in node equation. So, this will become current and 3 would be conductance. So, 3 Siemens conductance would appear between node 1 and the reference node, because in this case it is connected only in mesh 1, right. So, 3S conductance would essentially be connected with reference and node 1 only. Now, let us come to equation 4. We will discuss these two terms because both are same and both are defining something which is common to both of the nodes. So, first let us concentrate on those terms which are not common to both of the nodes. So, these two are nothing but the value of currents, and these are nothing but 8 Henry inductor and 5 Siemens conductance, which is connected to only node 2. Why it is now the inductor? Because if you see the voltage across inductor, it is L di by dt. So, I would be nothing but 1 upon L integral VL dt. Since this is the voltage term, so if you compare both of them, the value of inductance would be 8 and VL is nothing but voltage at node 2. So, this will now become the inductance and this will be again the conductance as we saw in the equation 3. So, these two are only connected to node 2. So, these would be coming in parallel, 5 Siemens conductance and 8 Henry inductance. So, we got 1, 2, 3 and 4 elements of the circuit. Now, let us come to the element which is common in both equations, and what will it represent? It will represent 4 farad capacitor. How? If you see this is nothing but the value of the current which is connecting two nodes, right. So, if this is the value of current, it signifies what? If you correlate with capacitor current, IC is nothing but C dV by dt. So, if you compare these two, this will be something called I1, this will be I2, and I1 minus I2 means the values which are connected between two nodes. So, finally, what we got is the capacitor which is connected between voltage V1 and V2. So, we connect the capacitor also now having value of 4 farad. Finally, what is left? We left with the equation 4 value, that is inductor current at t is equal to 0, because here if you see the value of minus 10 is coming, this is representing the current value. So, what is left is that voltage across capacitor was minus 10 volt. So, in case of dual, this would be current through the inductor. So, we will assume that this is again the initial case. So, here also you can say that inductor current at t is equal to 0 and value is 10 ampere. So, we will represent the initial current IL at time t is equal to 0. Now, how you will find out the orientation? Again, if you see this circuit, voltage Vc is opposite of the mesh current direction I2. So, that means now in this case the current would not go inside the non-reference node V2, but it will come out of the non-reference node V2. So, that is why the direction of the current IL is in this direction. Now, this is the circuit we came out while analyzing the mesh and nodal equations. So, this sometimes is very difficult when you have more nodes and more meshes. Then what you can do? You can use one analogy which we will discuss. You will construct the dual circuit by inspection. How we will do that? Now, with each mesh we must associate one non-reference node and additionally a reference node. So, what will happen in this case? There are two meshes which are there in the circuit. So, for each mesh, let us assume there is one node in both of the meshes and there is one reference node also. So, let us say the voltage is V1 and V2. So, by inspection also you can say that there would be two non-reference nodes, because there are two meshes being constructed, plus you need to additionally have one reference node. Now, on the diagram we place node at the center of each mesh and supply the reference node as a line near the diagram or the loop enclosing the diagram. So, you can say like simple node, or you can create a line for nodes, because it is easier for you to connect. So, you can represent reference in any form, like a long line having nodes at each node having same potential. Now, each element that appears jointly in two meshes is a mutual element. So, it must be replaced by an element that supplies the dual term in the two corresponding nodal equation. So, what will happen here? This is the element which is connected between two meshes. So, the dual of this would be what? The dual of this is capacitance. So, what you can write here, you can say that dual of this is capacitor. So, since it is connected between two mesh, in the nodal case it will be connected between two nodes. So, you can simply add these two nodes through one capacitor. Now, what next? The mathematical form of equations will be same only if the inductance is replaced by capacitance, capacitance by inductance, conductance by resistance and resistance by conductance. It means that these are the duals of each other. So, what you will do? This you have already identified that this will be the capacitance. So, you will make a capacitor. Now, the 3 ohm resistance, 8 farad capacitor and 5 ohm resistance are only in their respective meshes. It means that in dual terms they will be connected only with respect to their nodes. So, what will happen? You can just connect conductance having value of 5 mho or 5 Siemens. Similarly, for this capacitor, what you can say? You can say that the dual of this capacitance is inductance, value would be 8 Henry, and it will be connected between reference node and the non-reference node V2, right. Similarly, for this resistance, what you can say? You can say that the dual of this is a conductance having value 3 mho. Now, finally, what is left? The left value is the voltage source. So, in this case it will be nothing but the current source. Now, what would be the direction? Because direction of voltage is in such a way that it is giving positive current. So, the current will also be in such a way that it is going inside the node. So, the direction of current would be like this. So, in this way you can simply represent the values of the equivalent dual network. Now, the voltage across capacitor is the initial current through inductor in the dual circuit. What would be the value? Here the value is minus Vc, because it is opposite to the direction of current. So, the current would be minus IL, or alternatively you can say current of 10 ampere coming out of non-reference node. So, in this way the direction of current would be this, because voltage across capacitor is opposing the flow of the mesh current. So, that is why the direction of that dual current through that inductor would be coming out of the node. So, in this way, by analogy also you can simply represent the dual of a particular circuit. Now, let us take one example so that you can further understand what we discussed till now. Let us say that we have a circuit given in the figure where we have resistance, inductance are connected in series, and we have one capacitance, one resistance and one capacitance here between these two nodes. So, what are the various mesh currents? So, you may say that there are 3 meshes, that is I1, maybe I2 and I3, right. So, rather than writing the mesh equation and correspondingly finding out the nodal equation, what we will simply do? We will simply use the analogy. First, what we will do? We will first identify the nodes. So, there would be 3 nodes, because there are 3 meshes and plus one reference node. Mesh current I1 is flowing in the inductor in this direction, while current I2 is flowing from the upper mesh in this direction. So, it means that these are the current flowing through this inductor would be I1 minus I2. So, that means that in nodal terms, when you replace this inductor with capacitor, the capacitor should be connected between node V1 and V2. So, in this way we have connected node the capacitor between node V1 and V2. Similarly, for this resistance also the current is I1 minus I2. That means that the dual of this resistance, that is conductance, would also be connected between node 1 and node 2. So, we have connected this conductance in parallel with capacitance in this particular node. Now, we are assuming current I3 in this direction, while current I2 would be in this direction. So, this will show that the inductor dual, that is capacitor, again would be connected between node 2 and node 3. Similarly, for resistance dual, that is conductance, will also be connected between node 2 and node 3. Now next what we have left with is the capacitance value, that is between this side to this side of the circuit. Which current is flowing here? If you see, this is having only current I2, no any current is flowing. It means that the dual of capacitance, that is inductance, would be connected between node 2 and reference node only. So, that is why this is connected between node 2 and reference node. So, we have covered all the elements of this segment. Finally, we have left with this resistance, where only node the mesh current I3 is flowing. So, it means that this would be connected, the dual of this would be connected between node 3 and reference only. So, the conductance of this dual would be connected between node 3 and reference node. Now, we have left with the voltage source. So, voltage source is giving the positive current to the this mesh. So, that means that the dual of this would be a current source which would be coming inside the node. So, that is why the dual of this is represented as current source with current in this direction. So, using the circuit and corresponding the duals of each and individual element, we can draw the dual circuit. Now, let us rearrange it. The circuit would look like as shown in this figure, where you will see that capacitance and conductance, these two are in parallel. So, you have this is V1, this is V2, this is V3, that means node 1, node 2 and node 3. The capacitance and conductance are connected in parallel between V1 and V2. So, this is represented in this way. Now, between V2 and V3 again you have one capacitance and one conductance. So, you have represented in this way. Now, the element which is inductance is connected between node 2 and reference. So, you have got this conductance, and then you have another inductor which is connected between V1 and V3. So, this is the inductance which you have got, which is between node 1 and node 3, and finally, between node 3 and reference you have one conductance and the current source which is connected between reference and node 1. So, this circuit you can rearrange and represent it nicely, so that you do not have any ambiguity in representing the dual circuit. So, what we can say, what are the various dual parameters? Resistance R would be converted into conductance, inductance L would be converted into capacitance, voltage V would be converted into current I, voltage source would be current source in case of its dual circuit, node would be the mesh in the dual circuit, series path would be parallel path which we have just discussed, open circuit would will become short circuit, KVL would be KCL in case of its dual. So, this is what we started initially with. We started with mesh equations, those are nothing but KVL, and then we created dual with the help of KCL, that these are nothing but the node equations, and then accordingly we found the dual of the circuit. So, now with this discussion on the dual circuit, let us close the session of today's lecture. So, in this lecture we discussed about what is the dual circuit, what is duality. So, in the next lecture we will start with various network theorems like Thevenin's theorem, Norton's theorems and so on. Thank you.